Good morning, students. Today we are going to discuss about the P block elements. Okay, and this is the topic of BSc B.Ed second sem in organic chemistry. So, for this topic and for the P block element, the very first is the boron family. The boron family other members are aluminium, gallium, indium, and thallium. Okay, so if you go for the electronic configuration of boron, it is 1s2, 2s2 and 2p1. Okay, that means it has 3 electron in its outermost valence shell. Similarly for aluminum it is 3p1, for gallium it is 4p1, for indium it is 5p1, and for thallium it is 6p1. Now the hydrides of boron family members, hydrides of boron family. So very first is boron, so it has BH3, then ALH3, then GAH3, then INH3, and then TLH3. If you take example of boron hydrides or any boron trihalide, like if you go for the BF3 molecule, suppose. Okay, so many of organic chemical reactions you find that this BF3 is a Lewis acid. And why it is Lewis acid? See, this boron is electron deficient compound. Okay, because it has incomplete octet. So due to this electron deficiency, it will act as a Lewis acid. Okay, and if you have a NH3 which has one lone pair of electron and which can give this electron to this boron, and as it has a electron access, here electron deficiency. Okay, and here electron is as an access, so it is acts as a Lewis base. So boron family, like if you go for the BF3, then AlCl3 is there. Okay, these all are considered as a Lewis acid because of the electron deficiency. Now the very important for boron family is the diboron. As the name says, it is a dimer of boron hydride. So BH3 is there, and if you write the BH3 dimer, this will give B2H6. So this is called boron hydride, the dimer of boron hydride and diboron. The structure of diboron is very important and different also. This boron and this two boron is there, one hydrogen, one hydrogen, one hydrogen, one hydrogen, and two hydrogen. These four hydrogen, 1, 2, 3, and 4, are terminal hydrogens. Okay, these four hydrogens are terminal hydrogens. Now the bonding between these boron and hydrogen is just like other covalent bond, no different at all, because of sharing of electron is there. So this will consider as a this 4BHT are what? These are the covalent bond. Okay, but the bonding of this BH and this BH is quite different. What is different? This hydrogen has one electron, this hydrogen has one electron, this boron has one electron left, this boron has one electron left. Okay, now as you can see that here two electron makes one bond, here two electron makes one bond, but here we have only two electrons, and these two electrons will form this bond also and this bond also. That means there is two electron which are shared by three center B, H and B. So this is called three center two electron. This is called three center two electron. These two electron forms a bond between boron and hydrogen also, and this boron and hydrogen also. Got it? So this is called two centered three electron, and similarly happened with this. So the shape of this bond, the shape of this bond is different from other bonds, and the shape is look like banana. So this is called banana bond. That is why I'm saying that it is a different kind of bonding here. So these two hydrogen considered the bridge hydrogen, Hp. So we have two B, Hb, B, and this is called banana bond. Okay, so diboron possesses banana bond. Now let's discuss some of the other statistical terms. If you think and if you see that the bond length of this boron and terminal hydrogen, this is a pure covalent bond. Okay, so bond length of boron and terminal hydrogen is 1.19 angstrom. Okay, whereas the bond length of this boron and this bridge BHB is 1.23. So with the measurement of this bond length between the terminal hydrogen and boron atom and bridge hydrogen and boron atom, you can easily understand that this is not a pure covalent bond. So this is a covalent bond, and this BHB is actually a banana bond. This is a different from covalent bond. Okay, similarly if you go for the bond angle, the angle between HB and HTB and HT, the bond angle is 122 degree here, whereas if you look for the bond angle between what HB and H here, this is a bond angle. Okay, if you look for the bond angle between H bridge boron and H bridge, the bond angle here is 97 degree. So the bond angle is also different. Correct? So this is how you can differentiate this BHT and BHB. The statistical data clearly shows that this is a different types of bonding. Now let's check the hybridization at boron atom. So this B shows the sp3 kind of hybridization. This is sp3 because we have four hydrogens are attached, though it is attached with the 3 center electrons, so it will consider as a sp3. Okay, so the bonding is you must remember that it is a 3 center 2 electron bond. Why it is 3 center 2 electron bond? Because these two electrons are equally shared by three atoms B, H and B. Okay, so this is called 3 center 2 electron bond. Correct? So this is all about the banana bonding.